Let's take a look in this video at how we can do quality of service in a wireless LAN environment. Wireless LANs often support a feature called WMM or Wi-Fi multimedia. And what WMM does is it gives us four different categories for accessing the wireless network. It gives us four access categories, and here are their names. We have one for the background traffic, that's low priority. Best effort, just sort of average priority. We've got a class or a category for video and a category for voice. And on screen you see the different names given to those different categories. And how we put traffic in the categories is we take a .1p marking from a client and we put it in one of the categories based on that .1p marking. Now an 802.1p marking is supported by some network clients, and what we're doing is we're adding 4 bytes onto our frames. It's a lot like adding 4 bytes on a .1q trunk. In fact, it looks almost identical to that. The big difference is the VLAN field is all zeros. We're not identifying VLAN membership. We're just adding those 4 bytes so that we can use 3 bits in those bytes to identify the priority of a frame. So we've got 3 bits at our disposal. How many possible values is that? It's 8. 2 raised to the third power is 8. So we've got values in the range of 0 through 7. And on screen you see how the .1p markings in the range of 0 through 7 map to these different access categories. Now if we're in one category versus another, what exactly does that mean? Well, your category membership influences interframe space and the random backoff timer that you're going to be using. Here's what I mean. When we're sending frames out in a wireless network, there is a gap that we have between those frames. That's called the IFS, the interframe space. Well, for higher priority traffic, for example, the voice, the video categories, we start to use smaller and smaller interframe spaces, so we're sending more aggressively. Also, wireless networks can use CSMA-CA, carrier sense multiple access with collision avoidance. What that's going to do is it's going to listen to the airwaves to see if it's free to send right now. Now this is prior to Wi-Fi 6. With Wi-Fi 6 or 802.11ax, we start to move away from this a little bit, and we're given time slots in which we can send, so we don't have this contention issue. But traditional wireless LANs would listen to the airwaves to see if it's free to send right now, and if it is, they'll send. If not, they'll wait a random amount of time and they'll try again. Well, that random amount of time gets smaller and smaller as we increase our priorities, as we go up in the stack that you see on screen. Again, the idea is the higher the access category, the more aggressively we're trying to send our traffic. And that's the way that we can take a .1p marking on a network client and translate that into how aggressively we're going to be trying to send it on the wireless network. Now let's go out to a Cisco wireless LAN controller and take a look at how we could assign one of these WMM categories perhaps to an entire wireless LAN. What we can do with a Cisco wireless LAN controller, and we're sitting at the management screen of one of those controllers here, what we can do is assign different wireless LANs for different traffic types. We might put video in one wireless LAN, voice in another, and so on. And for the wireless LAN that I have, let's go under WLANs, and I've got one called CCNA that I use for my CCNA training. Notice that there's a tab that says QOS. If we go to that tab, we see that we can specify the quality of service for this wireless LAN. And these are the 4 categories we talked about: background, best effort, video, and voice. And right now, this CCNA wireless LAN is just set to best effort. But that's a look at how we could go in and set the access category for a particular wireless LAN on a Cisco LAN controller.